Okay, we want to find the equivalent resistance as seen from here. So we want to find replace the whole of this uh, with just one single resistance. So if we want to do that, first we start from the right, from because the source is here, so we start from the right uh, extreme here in this particular case. Maybe not always, but in this case usually it's always. So we can see that these two are coming in parallel, 40 and 10. So the equivalent will be 10 times 40. Two resistances, when they are in parallel, the equivalent can be found by multiplying them and then divided by the sum of those two. So 10 plus 40. So 10 and 40, so 10 times 40 divided by 10 plus 40. So that's 10 times 40 here, and then 50 here. So that gives us 8. So this resistance can be replaced by one thing. What I will do, I will erase this part and I will just redraw it. So these two can be replaced by one single resistance, and that resistance will be 8 ohms. So that's there. Now these two resistances are coming in series, and then that equivalent will come in parallel with this one. So we will do that. These two are in series, 22 ohms, 8 ohms. When they are added, because they are in series, they will be added. So that will become 22 plus 1, so that will be 22 plus 8, that will become 30. So 30 ohms there. Now this 30 ohms and 25 ohms, these two are coming in parallel. So 25 times 30 divided by 25 plus 30, which is 55. So 25 times 30 divided by 55, that gives here 11, and then gives here 5. So 150 over 11. I will leave it like that. So we can see that I will probably redraw in this situation. So that one is 18 ohms there, and then I have 100 ohms, and then here I have 150 over 11, if I recall it correctly. So 150 over 11 ohms there, 100 ohms there, and 18 ohms there, and this is a 60 volts. The value of the voltage source is not very important because we don't need to find current or anything, we just need to find the resistance as seen from here. So these two are again in parallel, and that gives us 100 into 150 over 11, over 11, and then 11. So those two will be added, so I can just write 100 plus 150 over 11, so that becomes 100 times 150, and here if I add it, this 11 and this 11 will get cancelled, so that is 1100 plus 150, so that's 1250. So if these two gets cancelled, this is just 2 here, so that's 200. Is it? Sorry, there is a mistake. 125 times 2 is not 250. So it will be 6 here and 5 here, and then this is 2 here, because I have divided 125 by 25 and 150 by 25, both of them by 25, so I get 6 here, 5 here, and then this is, so it's becoming 12. So the parallel combination is 12 now. So 18 ohms here and then 12 ohms there, that gives me 18 plus 12 is 30 ohms. So basically the resistance seen by the source will be just 30 ohms. So that's it. That's the resistance as seen by. So if we want, we can replace the whole circuit, whole resistances, the arrangements of the resistances by just one resistance. The whole arrangement can be replaced by one resistance. So this is another example. I will like to do that as well in this video. So here we can see again, we need to find the resistance as seen from here. Maybe different colors. So seen from here, and when we start from the right, we can see that actually, though it's drawn like that, 6 ohms and 18 ohms, they are actually coming in parallel. So these two are in parallel. That gives us 18 times 6 divided by 24, so that's 4 here, so 9 over 2, and then maybe I will draw here, sorry, redraw here. So that's a 50 milliamps resistance, sorry, current source, and that's a 100k there, 10k, and then 5k here. We have 2 kilo ohms, 9 kilo ohms there, and here it is becoming 9 over 2 kilo ohms. So the parallel combination of 9 and 9 over 2 becomes 9 times 9 over 2 divided by 927 over 2 when I add them. So that's like that. So this is becoming 3. So these two parallel combination is becoming 3. I will just draw here maybe, and so I can replace this whole thing by 3, replace this with 3, so that is becoming 3 kilo ohms. And then these three are this one, and this one, these three are coming in series. So 5 plus 2 plus 3, that is becoming, so the circuit we are getting here is, that is our 10 kilo ohms there, which was there already, and those three resistances, they are in series, so they can be just added to get a single resistance, and that becomes 10 kilo ohms as well. So 5 plus 2 plus 3 is 10. So we have here, what was the current source, 50 milliamps, and 10 kilo ohms, 10 kilo ohms, these two are these two have same value and they are in parallel, so the equivalent will be just half. So 10 times, we can just write the formula still, 10 plus 10 is 20, and that always becomes half when they are both the same. So that is 5. So the resistance that we get here, that is replacing the whole arrangement, that is, the value is 5 kilo ohms. So 5 kilo ohms, this is the resistance seen from here. Instead of all this arrangement, we can replace that with just 5 kilo ohms.